So today we are going to do pages 80 to 82. And on page 80, I'm just going to highlight some of the really important things that we need to know. Aside from the fact that you have a polynomial that's factored, the thing that I care about the most is the leading coefficient and the highest degree of the polynomial. Okay, so if my leading coefficient is positive and my highest degree is odd, then the end behaviors are going to look like this. It's going to start off negative and then it's going to go positive. In other words, we can say this: as x approaches negative infinity, our function is approaching negative infinity. And if x is approaching positive infinity, then our function is approaching positive infinity. Okay, so if we have a leading coefficient that is positive and the highest degree of the polynomial is even, then what happens is this function is going up and up on both ends, meaning as x goes to negative infinity, f of x is going to infinity, and as x approaches infinity, f of x is approaching infinity. Okay, now let's actually draw a graph so you can understand what this actually means. Let's talk about the first one, okay? We have a graph. As x approaches negative infinity, in other words, as I'm coming from the left, my function is approaching negative infinity. So I don't really care what happens in between. All I know is that as my x values go towards negative infinity, my function is also going down towards negative infinity. So it could look something like this. Okay? And then as x approaches positive infinity, or in other words, as I'm going right on the graph, my f of x, my y values, should be going to positive infinity, meaning they should be going up. So this is what I mean by it goes down on the left and it goes up on the right. Okay? On the other example, both of them are going up, meaning if I have a picture, that means as x approaches negative infinity, as I go towards the left of this graph, my function should go to positive infinity. And as my x goes to positive infinity, which is the right of the graph, my y values should also go up. So generally, the leading coefficient and the highest degree of the polynomials determines your end behaviors. Does it start from bottom and goes up, or do they both go up? Okay? If your coefficients are negative, well then the opposite happens. All right, let's also focus on the powers. Let's say that we have this kind of function. Let's take a look at our exponents, okay? So if you have an exponent of 1, then what's going to happen is you're just going to go straight through that 0. Okay? If you have an exponent of 2 or an even number, you're going to have a little bounce back. Okay? It's going to bounce. It's going to stay on the same side, stay on same side, whatever you want to call it. Okay? And then if you have a 3 or any odd number aside from 1, what you're going to do is you're going to have a squiggle, wiggle, curve, whatever you want to call it, at that root. Okay? Again, this will make more sense when we actually do the problem. And then this right here, this is really important, so just highlight this in your notes, the turning points. Okay? And this one pretty much says, if I have a function like x cubed, I know for sure that I have, at the most, 3 zeros or roots. At the most, like I can't have 4 or 5. It can only be up to 3. It also says that this graph only has at most 2 turning points. So this is just really important information that I want you to know. Okay? All right, now let's actually apply this by doing a problem. Let's go into the next page. All right, we have this example. We have f of x is 3x to the 4th minus 4x cubed. We're going to start with step 1. Step 1 says determine the end behavior using your rules and the leading coefficient test. So let's figure this out. The highest degree is 4. And our leading coefficient is positive. Therefore, my degree is even and my leading coefficient is positive. So what do I know about the end behaviors? Well, I said that if it was even and the leading coefficient was positive, then that means that on my ends, they would both go up. Okay, let's do number 2 now. Well, to do number 2, I need to find the zeros of the polynomial by factoring. So let's factor. What I can do is I can pull out an x cubed from both of my terms, and then what's left over is 3x minus 4. So now that it's factored, I'm going to look at my roots and I'm going to look at the multiplicities, and remember the multiplicities are those exponents. So we have a root at x equals 0 and we have a root at 3x minus 4 equals 0. I'm going to solve 3x equals 4, x equals 4 divided by 3. So we have 2 roots. Let's just graph them right away. I know that this point is going to be 0, 0, and this point is going to be 4/3, 0. So it's right here and roughly right here. Now let's focus on the exponent for those roots. So when x equals 0, that exponent, which I'm going to call k, is 3. And so what did I say when your exponent was 3 or odd? There was a squiggle, wiggle, or a curve, whatever you want to call it. So there's going to be a squiggle at the root 0, 0. Okay, and then for my root x equals 4/3, well, I have an exponent of that 1. It's not there, but it's an imaginary 1. And so if I have an exponent of 1, well, I know that my function is just going to go straight through that root. Okay, step number 3 is to just find a few extra points using a number line or test some points. So I'm going to make a table. All right, I'm going to plug in some random x values to figure out what those y values are. So if I plug in 1 into this equation, I will get -1. If I plug in 2, I'm going to get 16. If I plug in -1, I'm going to get 7. And I'm really just choosing random points. And if I plug in 0.5, I'm going to get roughly 0.6875. So now what I'm going to do is I'm going to plot these points, and then I'm going to combine everything that we learned, or that we gathered from steps 1, 2, and 3. Okay? So the first thing was we determined our end behavior. We said that it was the highest degree was even, and that my leading coefficient was positive. Therefore, the left part of my function and the right part of the function should both be going upwards. So I'm going to put these little up arrows right here. And so far this matches because right here I have a point at 216. I can only get to it by going up, so that makes sense. Great. Now I'm going to connect some points right here. And as I'm going through 0, 0, I notice that this is a root. And because of that multiplicity, because my exponent was 3, I've got to do a little squiggle at 0. So I'm going to try my best to do a little squiggle. There's that little squiggle. And then I'm going to that little point, going to connect the dots still. And then as I go up to the second root, well, I know that that exponent is 1. And so I'm just going to go straight through that one. And then I'm going to go all the way up to reach that point 2, 16. And so this is how this graph roughly looks like. There is a little squiggle or wiggle at the root 0, 0. We're going straight through at the root 4/3, 0. And then my end behaviors, they are both going to positive infinity. Okay? All right, let's do the next question on the next page. All right, so we're going to start off with step 1. We are going to figure out the leading coefficient and the highest degree. Now, the difference about this question is that this is already in factored form. So I have multiple degrees. What I need to do is I actually need to distribute it so that I can figure out what the highest degree actually is, because in this case, the highest degree is not 3. Now, we're not going to distribute everything because that would take too long. what I'm going to do is I'm just going to know that that negative 3 still stays in the front, but I have an x to the 1 power. I also have that this function is being eventually multiplied, like I'm doing a shortcut to finding the highest degree, that I have an x cubed, and that eventually, if I distributed this, I would also have x squared. Okay? And so like I said, this is a shortcut because I don't actually want to distribute everything. All I know is that if I did distribute everything, I would eventually get an x times an x cubed somewhere times an x squared. Okay? And I know that if I multiply the same base, what do I do with my exponents? I eventually add those exponents together. So my leading coefficient stays as the negative 3, and then my exponent, the highest power, will turn into the 6th power. So now let's analyze it over here, okay? My highest degree is technically the 6th power after we kind of fast distributed it, all right? This right here is even. I also know that my leading coefficient is not positive this time, it's negative. So we have an even power and a negative leading coefficient. Therefore, what does that tell me about my end behaviors? Well, generally, with an even function, if I had a positive leading coefficient, then both of my end behaviors would go up. Well, since I have a negative leading coefficient, that means that both of my end behaviors are going down. All right, now on to the second step. Now we're going to figure out our roots and its multiplicities. Luckily for us, they already factored it for us. So I know that I have a root at x equals 1, x equals negative 2, and x equals positive 4. So let's figure out their multiplicities by looking at the powers of each root. So this first one, when my root is x equals 1, I have an exponent of 1. That means at the root 1, 0, I am going straight through that point. Nothing is happening. I'm just going straight through, okay? At the root negative 2, we have an exponent of 3. And so I know that at an exponent of 3, so at this root negative 2, 0, there's going to be a squiggle, a wiggle, a curve, whatever you want to call it. Let's call it a curve this time. Okay? And then at my root x equals 4, my exponent is 2. So my k is 2. Therefore, at the root 4, 0, there's going to be a bounce back. It's going to stay on the same side. So let's draw those roots. We got 1, 0, negative 2, 0, and 4, 0. Okay, and for step 3, we would plug in random numbers, but the thing is if I plug in random numbers into this, I'm going to get really big numbers, so I'm not going to do that for this one. I am actually going to make a number line to test out if my values are positive or negative, because that's all I care about. So here's my number line. I'm going to put my roots on the number line. So we have one at negative 2, we have one at positive 1, and we have one at 4. And I am not actually calculating the numbers that I'm plugging in. I just care about the sign to see if my values are going to be above the x-axis or below the x-axis. So let's start with this first part on the left, okay? I'm going to plug in a number that's less than negative 2. So let's just say negative 3, okay? I'm not actually plugging in negative 3 into the timeline. I'm just figuring out what that sign will eventually be. So let's start. If I plug it into the equation, we have that negative 3 in the front. Here's this first part. Negative 3 minus 1. That's going to be a negative number. So I'm going to put that negative there, okay? Then I have negative 3 plus 2. Well, I know that that's also a negative number. It's negative 1, but I don't care about the number. But it's a negative cubed, okay? And then the last one is negative 3 minus 4. That's definitely a negative number, but this number is squared. So now all I care about is the actual sign, all right? So we have this. A negative 3 times a negative is positive. Then we have a negative cubed. Well, that's still negative. And then a negative squared is positive. So we have a positive times a negative times a positive. Well, ultimately, what does that turn out to be? That turns out to be a negative. So before, my values that are less than negative 2, those y values are going to be negative. I don't actually care what the y values are. I just care about the general direction of my y values. Okay, let's choose a number in between negative 2 and 1. Okay, we can actually try 0 on this. So let's try 0. If you really wanted to do the numbers, you could. So we have negative 3. 0 minus 1 is negative 1. Then we got 2 cubed. But then we have negative 4 squared. Okay? You can do the math on this. But if you don't want to do the math on this, we can just care about the signs like we've done before, right? Negative 3 times negative 1 is a positive value. Okay? 2 cubed is a positive value. And then negative 4 squared is a positive value. Therefore, a positive times a positive times a positive is a positive. Okay? We got 2 more to do. So if I plug in a random number like 3, I have negative 3 times a positive value. So I'm just going to put positive. Okay? Positive to the third power. And then it's going to be negative squared. Well, a negative squared is still positive. So we have a negative times a positive times a positive times a positive. This overall is going to be negative. Okay? And then this last bit, let's just imaginarily plug in 5. Okay? That negative 3 is still in the front. 5, positive 5. All right? So if I plug in positive 5, this first term is going to be positive. The next one will be positive cubed. And then this last one will be positive squared. Okay, but since there's that negative 3 in the front, it's overall going to be negative. So here's our timeline. If you really care about the number, then I'll give it to you. If you actually plugged in negative 3, you will get negative 588. If you plug in 0, you get 384. If you plug in 3, you get negative 750. And if you plug in 5, you get negative 4,116. So yes, clearly, if you actually plug in the numbers, 1, you're going to be spending a lot of time, and 2, they're really big numbers, so don't spend your time doing that. Just plug in the values to get your positive or negative signs. It's a lot faster that way. Okay? So now, let's put it all together. I know that based off of my n behaviors, because I have an even degree and a negative leading coefficient, as x approaches negative infinity, my y values are going to approach negative infinity, meaning it's going to come from here. Okay? Same with the right side, it's also going to go down as well. So now I know I have to go through the roots. So as I am going through negative 2, based off of that multiplicity, there is going to be a little curve at negative 2. So let's try this. There's that curve. Okay? This also matches the timeline because every number that is less than negative 2 is negative, and that matches with our y values. Okay? Then as we pass negative 2, all our y values become positive. We're going to 384, so it's definitely going to be super steep. So it's got to be really steep. And then all of a sudden, we do have to come back to go through this root at 1, 0. And so what happens at 1, 0? It says there's a straight line. So as it's coming up, I got to come back down eventually. There we go. There's just that straight line through 1, 0. Okay? And apparently, at 3, I go to negative 750. Well, that's also really steep down there. But again, I have to go back through that root. And so we have to come back eventually to reach this root. And then at 4, what happens at my root 4? It says that I bounce or I stay at the same side. So I'm not actually passing that root, I'm staying on the same side. It's going to look like this, and then I eventually come back down. So this is roughly how my function looks when I graph it. And so let me show you how this function actually looks like when it's graphed out. And so if you take a look to the graph that I just put in, pretty much ours follows the exact same pattern. And so if you have a more complicated function, just do this 3-step process. First, determine the end behaviors and the leading coefficients by checking the degree. Then find the zeros by factoring and determine the multiplicity so we know what happens at those zeros. And then the last one is either test a few points or use a number line so that you can figure out what those y values are, and then just piece it all together, and then you will have your graph.